Alright guys, so let's start off on number 1 here. So we know that, like it says here, the square root of -1 equals I. So whenever I see a negative inside of a radical, I kind of automatically think of that I. And so if you want to, what you can do is take the I out front and then just deal with that radical as a positive 144 now. Since the square root of -1 is I can just take that outside. And then obviously the square root of 144 is 12, so this just turns into 12I. For number 2, for this one, same idea here. So I would just look at this as I times the square root of 25, and then that just turns into 5I. So we have here 8 plus 5I. Those are kind of unlike terms, so we cannot combine them. So that's just our answer. All right, next up we got number 3. So we're multiplying two radicals that have a negative inside. Now these are both imaginary numbers, which means we aren't allowed to combine them by multiplying into one radical. We have to kind of, on both cases, take the I outside and look at it like this, with positive numbers in there and then the i's out front. So then if I multiply the i's together, that'll give me I squared. And then if I multiply the radicals, it'll give me rad 81. Now we know that that I squared is -1. And let me get some more space here. And so that's going to be -1 times 9. And so that'll be -9. All right. Next up, number 4. There's a couple different ways to do this one. The method I like to use is I always like to rewrite this. If it's an odd one, take an I over here and then call this I to the power of 76. And the reason I like to do that is that now what I can do is rewrite that as I times, I'm going to call this I squared on the inside, and then on the outside, get a good squared there. On the outside, I'm going to do whatever 76 divided by 2. Because I know that property right there is multiplication, so I can kind of do it backwards by division. And so I put an 8 right there, so then this is the power of 38. So the reason I like to do that is that now I know that I squared is -1, so I can rewrite that there. And so now I have -1 to an even power, so it's actually I times +1, which would be I. There's another way to do it by taking 77 divided by 4 to start with and looking at the remainder. So if you know that technique, you can use that as well. All right, next up, number 5. I really just think of this as combining like terms. And so we're just going to do the 2 plus the 6 is an 8, and then -3i and +1i is just -2i. That's it. Number 6 is also combining like terms, but I just got to distribute that negative first. It'll be -1 plus 5i. And then we'll combine like terms with this one. So we'll do -5 plus 13i. Next up here is just a FOIL. So I'm going to multiply that times that is 6. And then we have a -21i, a +16i, and then a -56i squared. Now the only difference about this FOIL is that we end up with a -56i squared here. Now remember, I squared is really -1. So this is actually a +56 right there. So with that, I'll have some more terms to combine here. You should never be left over with an I squared because you can always simplify that to -1. This has become 62 and then -5i. All right, number 8 and 9 here, we're looking to simplify these. And so kind of the goal here, they never really tell you that's the goal, but your goal is to get I out of the denominator. And so we have a couple different ways to do that. When it's just an I down here, or if it was actually, this would be the same case if it was like something over 2i instead, we would always multiply by just I. Even if it was just this one, I would still multiply that one by I, top and bottom, whatever that was. And that turns that bottom into I squared, which we already know is -1, but I do have to distribute that up top as well. So it's going to be 6i and then -2i squared. Now -2i squared, I kind of just look at that as being +2, and then we had a +6i there. I would just simplify this by dividing both of these by -1. And so it's going to be -2 minus 6i for my final answer. Number 9 here, we have a complex number on the bottom, so that means I need to multiply by the complex conjugate. That is always kind of the same first term, but a different second term. So I'll do that on top and bottom. On top, I'm going to need to distribute. Sometimes you need to FOIL this, but in this case, it's just a distribute. So 20i minus 59 squared. On bottom, you can actually just do a fl, since those are conjugates, so that's what I'm going to do. It's only allowed here for conjugates, so this is exactly the case when we would want to use it. Okay, so then we can simplify on top and bottom. We know that this is really plus 15. So I'm going to move it to the front. Usually they have the I in the back. And then down here, we know that this is really plus 9. So I'm going to put this over 25. And then we'll go ahead and reduce this. So all three of these numbers together. So they can all reduce by 5. So it'll be 3 plus 4i, all over 5. Now, sometimes they will split this up and write it as two fractions. Both are acceptable. Next up here, number 10, these are perfect squares, but they're not subtracting, they're actually adding, so I cannot factor it, so I'm going to just isolate my x here, so divide by 25, and x squared equals negative square root of, nope, the negative's on the inside, so it's the negative 16 over 25, and then I'll take the square root. Now, since I created that square root, I need a plus or minus there, and then we know that this is really, I can take an I out front since that whole fraction is really negative and just call this 16 over 25, of course, plus or minus. So then I can say x equals plus or minus 4 over 5i. Just taking the square root of the top and bottom of that and then attaching the I out back. Number 11 here I see is a trinomial, so you can try to factor this multiplying to 3 and adding the negative 3, but no numbers work. So we're going to say we use quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll just simplify this. It's 9 minus 12 is negative 3. And then we see here we do have a negative in the radical, so we want to go ahead and take the I out front. I don't see anything I can simplify, so we'll just leave our answer like that. Once again, especially with I, a lot of times they will separate these two. I would say it's fine either way, so just be aware that it may be written a couple different ways. So number 12, we want to get one side to 0 here, so I'm going to subtract 2x from both sides. So we get 2x squared minus 2x plus 3. Once again, I could try to factor multiplying to 6 and adding the negative 2, but it's not going to work there, so we get quadratic formula again. Oop, that's not 1 there. It's actually 2, and then 3, all over 2 times 2. So we have, what is this? 8 times 3 is 24, so 4 minus 24 is negative 20. And now I'm going to just turn that into a positive 20 and put an I there. And it will break down 20 just like we normally would. So we're going to have a 2 going outside. So 2 plus or minus, now it'll be 2i rad 5 all over 4. And we'll just go ahead and reduce these again. So we get 1 plus or minus I rad 5 all over 2 now, which once again, they may split up.